Okay, we're going to look at a very simple example of the superposition principle for electric field. And it's simple because we're only going to consider the a problem where the charges lie on a line, and so we're going to be interested in their net effect at a point along the x-axis. So let's consider first of all a charge at the origin. So let's not make this x equals 0, and we'll just put a charge here, and we'll make this a I don't know, let's make it a 3 nanocoulomb charge. So this is at the origin, x equals 0. And we'll put another charge over here, and we'll make this a 4 nanocoulomb charge. Now let's take a point let's take a point closer to the 4 nanocoulomb charge, and we'll set that to be x equals 3 meters. The 4 nanocoulomb charge will be at x equals 4 meters. Alright, so what do we have happening at the open circle at x equals minus 3? Well, first of all, there's an electric field from the 4 nanocoulomb charge, and it's going to be pointing to the left in the negative x direction. So it'll just be a vector pointing this way, and we'll call that E sub 4 for 4 nanocoulombs, and it's a vector pointing to the left in the negative x direction. Okay, so what about the effect from the 3 nanocoulomb charge? Well, there's going to be an electric field at the open circle which is pointing to the right in the positive x direction. Now we'll call this E sub 3, and it's a vector. Okay, so now we have these two vectors. They add together, and remember this is a vector addition, so we're going to get a vector which is pointing to the left but slightly smaller than E4, and I'll call this E net. Okay, so it's E net that we're interested in finding. So from the superposition principle, E net as a vector is equal to the sum of E3 and E4. Now, because this is all on a line, we can just add the x components of each vector together. So if we look at E3, E3 is pointing in the positive x direction, so its x component is going to be k times 3 nanocoulombs. You know what? I'll make that a 3 times 10 to the minus 9 coulombs, and we're going to divide it by the distance the open circle is away from our 3 nanocoulomb charge, which in this case is 3 meters, and we have to square it. Alright, so this is the x component of E3. Now the x component of E4 is, first of all, it's negative because it points in the negative x direction, and its magnitude is k times 4 times 10 to the minus 9 coulombs divided by 1 meter squared. Now keep in mind that k is equal to, well, we're going to take the gross approximation of 9 times 10 to the 9 newtons meter squared over coulomb squared. Okay? So, if we are to add these two terms together, well, first of all, what does E3 become? Well, k times 3 times 10 to the minus 9 gives us 27 over 9, and our other term gives us 36, and there's a negative sign there giving us a subtraction. And I've dropped units here, and both of these terms have units of newtons per coulomb. So you can see where this is going. 27 over 9 is 3, so we have 3 minus 36, which is minus 33 newtons per coulomb. Alright, now this answer makes sense. We have a negative x component for E net, and we know that. We can see it in the picture that E net points to the left, so we expect this negative sign. So this is just a simple one-dimensional example of the superposition principle for electric fields.